Hello everyone, this is a lesson on S4, forces, load, and stresses, and we're just really taking a look at the class notes for this particular lesson. So first thing we're going to be taking a look at is external forces. External forces are simply forces, go figure, forces that act on a structure from the outside of the structure. So we'll put the word outside there. Right? These are forces that are acting upon an object. Now, these forces will actually produce internal forces or stresses actually on the object and from within the material themselves. And this is where the damage is actually caused. And the damage is what we call a deformation. Right? So the external stress is whatever we put on the outside. The internal is what we see inside the actual material, and it's what's happening inside the material that causes the deformation. Now we've got two types of external forces. The first one is what we call a dead load. Now a dead load is just a permanent force acting upon the structure. This would like to be the weight of the structure itself, or something that is always acting upon the structure. Weight being a very common one. And the second one is a live load. Now a live load is a changing or non-permanent force acting on the object. So for example, me hitting an object would be an example of a non-permanent force. Okay, or me sitting in the chair. Me sitting is not a permanent force because I get up, I get down, I get up, I get down. Okay, now there's the actual weight of the object, or kind of like a continual soft force, and then there's the actual impact force. Things that are colliding with the structure that are also, both of these are live loads. Now these external forces cause internal forces. So external is things happening outside the object, right? And but they do cause things inside the object. So we do not see these internal forces without the external forces acting upon the object. And so now we're going to take a look inside what's happening. Four types of internal forces. And the first one is a tension force. Now a tension force is basically a stress pulled the ends apart. It's basically a stretching or a lengthening of the material. That idea of stretching. A stretch would be an external force causing tension within the actual object. Okay, so this here, that is the external force. This is the internal force. And the stretching could be a live or a dead load depending on the situation, but the stretch would be the external, tension is the internal force. And so in that internal force there, we got a tense, so a particular material will have a tensile strength, which is the largest tension force the material can withstand before failing. Okay. So the next one we're going to look at is compression. Okay. Now a compression force will crush material by squeezing it together. Okay, and so the crushing here That crushing is the external force. Again, this is external. Where the compression strength is the internal force. It's what's happening inside the material caused by the crushing that will move the particles together. Okay? And so we've got compressive strength, which measures the largest compression force that the object can take before it fails. Thirdly, we've got the shear force. Right? And this is a bending or tearing. And again, as before, the tearing is the external force acting upon the object. Shear is the internal force. It's what we're seeing within the particles themselves inside the material. Right? And this is done by basically moving pieces in opposite directions. At the same time. Now, a shear strength of a material is the largest shear force it can stand before it rips apart. Right? That tearing, again, that external force, some things are better able to handle this than others. And the fourth one we've got here is the torsion force. Torsion forces are essentially caused by twisting motions. And so that twisting is the external force acting upon the object. Torsion is the internal, what we actually see happening within the molecules. Okay. Torsion strength measures the largest torsion force that it can withstand before and still spring back into its original shape. So withstand and still spring back into its original shape. So if we take a look, we've got a little diagram with each of these. Tension, we see it's being stretched, they're pulled apart opposite, where the forces are pulling away from each other on opposite ends of the object. Internal compression forces, again, they're two forces going in different directions, but they're going towards each other, right? So this is away, this is towards. So how is a compression force different than a shear force? Well, these are, again, towards, but they're at different points. 2 different points upon the object, right? The forces are moving towards each other, but at different spots along the object causes that shear force. And that torsion force is going to be usually one clockwise and one counterclockwise motion acting upon the object. Now, some other things such as bending. A bending force, bending does not just do one of these. It will be a combination of forces. Now, bending is, again, an outside force, right? But it causes a combination of tension and, so actually instead of saying is, we should say causes a combination of compression, tension, and even sometimes shear forces. Now, if we take a look at what's again happening inside here, as this object is being bent, we're pulling here and here. This would be, again, the external bend. So we see a compression happen here. Spot at where the particles are being squished together. We see that compression happening. Tension on the other side. And in between, right along this dotted line, you see this shear force happening, right? Where we've got essentially, if we take a look just right here and here, we've got two forces moving side to side at different points, one above and one below. And so we see three different forces happening, internal forces happening, causing by the external bending motion. Okay. Now, shear and torsion forces really usually just are various combinations of tension and compression too, and so we see tension and compression happening. Each material, again, as we've kind of already alluded to, has a strength to it for each of these four basic internal forces. Okay, and these can be traced down to the tiniest particles within the object. Just thinking about that stress, we've got four internal forces, four types of material strength, and there are some objects that will have high strength and some that will have low strength in these things. Something that has a high tensile strength would be like a rope or a chain, right? It is something that you can pull both ends and it's not going to deform. Something with a low stretching ability to stretch might be something like an elastic band. An elastic band can take a whole lot of, it can take, as we apply just a little bit of force, it's going to start to deform, it's going to stretch. Now it bounces back in a lot of cases, but there's there. If we take a look at a compressive force, let's say like a full pop can, right? Now I should emphasize that this is probably closed. It is going to have a very high compressive, right? If we were to try to squish that can, we would have a very tough time doing it. But the empty one will wind up squishing with a lot less force. And so it has the empty pop can has a low compressive strength. The full pop can has a high compressive strength. Shear forces, things that we have a tough time bending. This might be something, let's say, like a table, right? We have a tough time trying to rip a table apart. However, a piece of paper might be very easy. So paper will have a low shear strength, where a table will have a high shear strength. Torsion forces, things that we have a difficult time twisting. Twisting might be something, let's say, like a metal rod. We have a tough time twisting a metal rod. If we have a metal rod here and we try to twist it at the ends, right, like this and like this, we're going to have a tough time with it. However, those empty water bottles, I know students love doing this, where they'll twist the bottles to the point where it pops the caps off. Yeah, so an empty water bottle will have a low torsion strength, where a metal rod will have a high torsion strength. Okay, and so these are just some examples to help bring some clarification to that. If you got any questions, let me know, and have a great day.